So the method that I'm talking about today is this method called factoring by division by a known factor. And what that means is that there's a certain style of problem where if you already know one factor, it makes it easy for us to factor the rest of the problem. So for instance, if I asked you to factor x cubed minus 5x squared plus 2x plus 8, given that x minus 2 is a factor. So something that's worth mentioning is, what does it mean, and this is important, what does it mean that this is a factor of this? Good. If it's a factor, and what she had said, if it's a factor, it means it divides in evenly. Yeah. That's what it means to be a factor. If it's a factor, it'll divide in evenly. So why don't we do that? Let's find out how many times this thing goes into this. And the best way to do that is using synthetic division. Right? So remember what the setup is for synthetic division. We take the opposite of this number here. So we take 2 and we put it out here in the box. And then what goes next to that? 1. Yeah, all of the coefficients of the thing. So we take 1, which came from here. And then we take minus 5, which came from here. Then we take 2 and 8, all in order, which came from these values up here. Right? Now, I assume you guys know how to do synthetic division. I'm going to pause this for a minute while you guys all do that division and make sure it works. Great, so doing the synthetic division, I assume you guys brought the 1 down. And then, we multiply that up to the 2. That gives me 2 here, negative 3. Negative 3 times 2 is negative 6. It's negative 4, negative 8. And we get 0. Yay! We win. Now, the key, crucial question, what I'm about to say is the entire lesson. The next step is everything in this lesson. Right? What does that mean? Yeah, the title for this lesson was Factoring by Division by a Known Factor. What it means is my original problem, this x cubed minus 5x squared plus 2x plus 8, it means I know how to factor it. It's going to be x minus 2 times what? Times the answer that we got out of synthetic division. Right? That's what it means to divide. Right? I found out that x minus 2 went into this thing, x squared minus 3x minus 4 times. Yeah. So we were able to take something that was not factorable. If you guys tried, what's the only method you could use on this? Grouping is the only method we have for quadnomials, which isn't a real word. And grouping doesn't work there. So it only helps that I knew that x minus 2 is a solution, and it went in this many times, so I wrote that down. The question, and I'm putting this in for the video, the question is being asked, why couldn't we use grouping? Let's step to the side for a second and take a look. If you try and do x cubed minus 5x squared, minus 2x plus, it was plus, wasn't it? Plus 2x plus 8. What happens when you group? You can pull an x squared out of this one, you're left with x minus 5. You pull a 2 out of this one and you have x plus 4. And what's wrong? These two things don't match, which usually means we did something wrong. In this case, it just means grouping didn't work. Because grouping doesn't always work. Grouping only works in certain circumstances. You guys have just been very fortunate that Mr. Chan, who does a good job making worksheets, makes all of his quadnomials work with grouping. Certain ones work, certain ones don't. And when he makes the worksheets, he makes sure that they work. Right? So this is a polynomial with 4 terms that grouping wouldn't work on. So fortunately, they gave us one term, this guy here, and we were able to factor it into this. And we're sort of going to mix a method here, because I would also say we're not done yet. Right, why am I not yet done? This is done being factored, but this thing over here is now a trinomial. we should look at whether or not this thing can be factored. And I hope that it can. I designed it to be factorable. If we attempt to factor this thing, what method do you use?
X.
We use our x method because we basically always use that method when it's a trinomial. I need two things that multiply for -4 and add for -3. Those numbers are -4 and 1. So what do we do with those numbers? Yeah, and some of you are aware that when there's nothing in front of the x squared here, we can actually just grab these numbers and factor with them, right? So you keep the x minus 2, yay, and then this thing will factor as x minus 4 times x plus 1. And congratulations, you're done factoring. So we took something that was previously not factored, but was not factored by grouping, and because they gave us a factor, we were able to divide by that and finish doing the factoring. So here we go. I did want to give you guys another problem to try on your own, so here it is. Factor. Let's see here. 2x cubed minus 3x squared minus 31x minus 12, given that x plus 3 is a factor. So take a minute, try that one on your own, use the same steps we did for the previous problem, and see if you can get to the end of that one. So based on the responses from the class, I messed up when I wrote this problem. Let's see what happens. First, is this thing really a factor? Let's see if I even got that right. Does -3 go into this thing? So we set up our synthetic division, bring down the 2, that's -6. This is -9. -9 and -3 is 27. Add those up and you get -4. -4 and -3 is 12, so we end up with 0 here. Yay! So that means that we can write 2x cubed minus 3x squared minus 31x minus 12 as... And so what's the first factor that you write down? We would normally write down x plus 3 first. And then the second term that we write down will be the 2x squared minus 9x minus 4. And if I had been more careful when I wrote the problem, you would have found that this thing can factor. But what you guys found, I hope, was that when you try and do this and look for two numbers that multiply for -8 and add for -9, they don't exist. If they had existed, you would split up this middle term, you would factor that as necessary, but they don't. I think I should have made this a +8 is what I should have done, and I didn't. So given that the last one didn't work, we've got one new one here. Go ahead and factor that polynomial completely, given that x minus 1 is a factor. So here we go. The first step is we find out how many times this goes into this. So we set up a little synthetic division. I've got 3, -10, 11, -4, 3, 3, -7, -7, 4, 4, and 0. Right? So at this point, how can we rewrite my 3x cubed minus 10x squared plus 11x minus 4? It's a really bad 11. How can I rewrite that? So we have the x minus 1 that he told me was a factor. And then there's the 3x squared minus 7x plus 4. And then for the next part, I just have to figure out how to factor this. Right? Because it's a trinomial, basically the one method we use for trinomials is that x method. I need two things to multiply for AC, which is 12, and add for B, which is -7. Those two numbers are -4 and -3. Right? So then what do you do with those? Yeah. Good. We basically use them to rewrite the middle term here. So I've got 3x squared minus 4x minus 3x plus 4. And at this point, it's a factoring by grouping problem, right? I group these two together and these two together. We still have this x minus 1. From those first two things, all I can factor out is the x. From the second two things, seems like they have nothing in common. We just pull out minus 1. And then, because these two things are the same, and you guys know this factoring method, we can put those things together, and we end up with x minus 1, because it was there all along, another x minus 1, and then 3x minus 4. Okay?